everybody. So let's make the paddle move, and then let's tackle how do we make the ball bounce off the paddle. Alright, so we're going to have the paddle move using the keyboard. So I will put all of that code here before the bouncing. You can check how all of this works inside your packet under the section for how do you respond to keyboard events. But what I'm going to do is I'm going to say if key pressed equals true. You see key pressed is highlighted in blue, and that's one way you can know it's a built-in variable. Key pressed is true exactly when you are holding down a key. So if we want the ball to move whenever we're holding down a key, you got to put an if statement to test for it. Okay, but we want to respond to different keys. So once we know that a key is being pressed down, let's try this. Let's test for which key is it. So if I want to use the arrow keys, those are special keys, so I use the key code variable. So I'm going to say if key code equals left. All of these are built-in variables. So key code will tell you if a special key is being pressed down and which one. Left is a built-in variable that matches to the left-hand key. So if the key code equals left, I know I want my paddle to move left. And the only way for that to happen is for the x coordinate to get smaller. So I'll say paddle x equals paddle x minus maybe 4. Now I can say if key code equals the right key, then paddle x equals paddle x plus 4. So now when I run it, you have to make sure you've clicked inside the window, but I can move the paddle to the left and right, and that seems to be working. So what I want to do is I want to extend what we already know about how to make the ball bounce off things. So remember the coordinate system. 0, 0 is on the upper left, and as the y coordinates increase, they go downwards. So in other words, a y coordinate of 600 is down here, and this is an x coordinate of 0. And then over here, you have an x coordinate of 600, and then up at the top is a y coordinate of 0. Here it might help us remember if I wrote x equals and y equals. Okay, so this is y equals and this is x equals. Okay, so before, you had code that tested to see is the y value of your ball below 600, because that was a way of testing whether or not it had crossed this threshold. All right, so now I'm going to draw an exaggeratedly large picture here. So we got to test for a couple of different things. We have to test to see is the ball far enough down to be hitting the paddle, and then we have to test is the ball kind of horizontally centered on the paddle. Because if the ball is down far enough but it's over here, obviously it's not hitting the paddle. And if the ball is centered on the paddle but it's up here, clearly it's not hitting it. So we got to put together several different tests at once. So before you had a test that said if y is greater than 600. So I think the new thing we want to do is figure out where is the top of the paddle here. And we want to test to see if the bottom of the ball has crossed the top of the paddle. All right, well, if you remember where we're drawing the paddle, the coordinates of the paddle are, I think I called them paddle x, paddle y. So that's this point right there. So what I'm about to write is going to be slightly wrong, but we'll fix it in a second. So I might say if y is larger than paddle y, then I want to do some stuff. Okay, so what's the problem with this? Remember that y is actually the center of the ball object. So imagining, let's sort of zoom in on this portion. So this giant thing here is the paddle. So let's pretend the ball was right there. In this case, here's our ball y coordinate, and then here is our paddle y. And you'll see that the y coordinate isn't below the paddle y. The y coordinate is still above the paddle y. So this test to see if we're hitting the paddle is going to tell us no. It's going to say false. We are not hitting the paddle. But obviously in this picture we are. And the reason why is because it doesn't matter if the center of the ball hasn't crossed the line. What really matters is, has the bottom of our ball crossed this line? Okay, so if the coordinate of the center of the ball is y, what's the coordinate of the bottom of the ball? For that, you have to know the radius of your ball object. My radius is, well, I don't know what it is. I'll have to look at it. But let's just pretend it's 30. If this y coordinate is y, then this y coordinate would just be y plus 30. because I've gone down by an additional 30. So what we need for our test is we need to say if y plus 30 is greater than paddle y. Later on, you're going to need to take these same building blocks and use them in a different way. So don't just copy this down and think you're good. You got to actually know where it comes from. So in my head, I'm thinking, where does this come from? What I really want to say is if, let me find a better pen here. This is the coordinate of the bottom of my ball. So if the bottom of the ball, and then this is below, so if the bottom of the ball is below, and then this is the top of the paddle. So that's kind of normal English. And later on, you could imagine if your paddle was sideways and you needed to see is something hitting it from the side, you're going to want to modify this. You're going to want to say something like, here's the paddle, is the left-hand side of the ball to the left of the right-hand side of the paddle, because that's how you would test to see if it was crossing that way. So being able to take an English language description of what you want to be seeing and then create a test for it that uses the actual coordinates of your screen. That's kind of the hard part of this whole exercise. All right, so we've got the one test. We're testing, is the ball below the top of the paddle? The other thing we need to test is the ball horizontally centered between these two things? So I'm going to say, let's see, this one is paddle x, and my ball's x-coordinate is x. And then this coordinate over here is paddle x, so the distance to paddle x, plus whatever the width of my paddle is. So if my paddle is 100, then that would make this paddle x plus 100. All right, so if my ball is far enough down, now I want to have two more statements. I want to ask if x is larger than paddle x, and also, is x less than paddle x plus 100? And then my bracing matches up like this. So this matches there, this matches here, and then inside here is where I would actually want to make it bounce. Okay, real quick, how do you think about this? So if ball x is larger than paddle x, what does that mean? I'm thinking on the screen. So here's paddle x. So anything larger than paddle x is over here. Kind of anything covering where this arrow is. That's all the coordinates larger than paddle x. Okay, and also x has to be smaller than paddle x plus 100. Here's paddle x plus 100. So all of the coordinates that are smaller than paddle x plus 100 are these guys here. Okay, so if those both have to be true at the same time, look at where those arrows overlap. That is only the arrows that cover the paddle. So that's why we have our tests that way. Okay, last thing. So let's pretend my ball is entering this way. It's going to hit the paddle. So kind of naturally, I would want it to bounce out like this. So the way that our ball motion happens is we've separated it into x speed and y speed. So the x speed is about how is it moving horizontally. So notice that as my ball is coming in to hit the paddle, I'm moving to the right. And then I hit the paddle, and as I move out, the ball is still moving to the right. So what that means is that the x speed hasn't actually changed because my horizontal motion hasn't changed. Yes, I'm bouncing, but the whole time, here, watch my two fingers. So this finger is going to move at a constant speed this way. This is going to bounce. So bounce and come back up again. So see how even though the finger that bounced is bouncing, its horizontal motion didn't change. So I don't think we want to reverse the horizontal speed. I think that we want to reverse the vertical speed because it used to be going down, and then when it hits, we want it to bounce back up again. So let's say reverse y speed. And you should already know the building block for how do you reverse the y speed. Okay, so I think that's enough to go on. I'm not actually going to show you the code. I want you to, we more or less have the code, but I want you to experience typing them for yourself. I will show you what the finished product should look like. The finished product looks something like this. So as you can see, the ball is bouncing off the paddle. But then if I miss, it goes off the screen. Okay, you might have noticed that actually, if you look closely, it's not bouncing off the paddle. It looks like it's bouncing off the thin air slightly above the paddle. If this happens to you, what that means is that you got the radius of your ball wrong. You're using the diameter of your ball instead of the radius. Because if you remember where you draw the ball object here for the ellipse, whatever number you have here is not the radius of the ball, it's actually the diameter of the ball. So if you're experiencing that, you can go ahead and fix that problem as well.